Okay, let's just look at the calendar for a second. It's February 6th, 2026.
Right.
Usually when we talk about a paradigm shift in tech, we're talking about, a paper in some obscure journal.
Or a prototype on a lab bench somewhere. It's always 5 years away.
Exactly. The battery world's favorite timeline, it's always 5 years away. But yesterday,
Was different.
yesterday, February 5th, something happened that kind of stopped the clock.
Right.
We are not talking about a lab experiment anymore. We are talking about assembly lines.
Real cars, actual passenger cars rolling off a production floor. It's a massive pivot point.
It feels like we've moved from could this happen to here are the keys.
Literally, yeah.
And the headline, I mean, if you strip it all down, it sounds like something from a sci-fi novel. We are talking about cars powered by salt.
Well, sodium.
Right.
But yes, chemically speaking, you're driving on the same element you sprinkle on your food.
It sounds wild, and that's really our mission for this deep dive. We're looking at this breaking news from yesterday, this battle of the chemistries, sodium-ion versus the reigning champ, lithium-ion.
And our goal is to cut through the hype, because the reality is actually more interesting. It's about supply chains, molecular stability, and solving, the biggest headache for EV owners in cold climates.
The dreaded winter range cliff. We are definitely getting to that because the numbers in these reports are just staggering. But let's ground this first. What actually happened yesterday?
So the event was in Yakeshi, Inner Mongolia, and the location is important.
Right. Not exactly a flashy showroom in Shanghai.
No, it was a deliberate choice. Yakeshi is brutal. It's a winter testing ground known for extreme sub-zero temperatures.
So it's a statement of intent just by being there.
Precisely. The core news is that Changan Automobile and CATL, the absolute titan of the battery world, they jointly unveiled the first mass-produced passenger vehicle with sodium-ion batteries.
And let's be clear for everyone listening, this isn't some concept car that's going to disappear into a museum.
No. The official launch is mid-2026. In car terms, that's tomorrow. The supply chain is already running.
That speed is just incredible. But let's look at the players. CATL isn't some scrappy startup.
Far from it. They're the market maker. They've been pouring resources into sodium-ion since about 2016. The sources say an investment of nearly 10 billion RMB.
Which is what, about 1.4 billion US dollars?
Something like that. A dedicated team of 300 researchers, 20 PhDs, all focused on cracking the sodium code. This wasn't a side project.
And they've branded it Naxtra, right?
Correct. The Naxtra battery. And Changan is deploying it across a bunch of their brands. The first model is the Nevo A06.
Okay, so we have the who and the when. I want to get to the why. Lithium-ion seems to be doing fine. My phone, my laptop, my car, it all works. Why pivot to sodium now?
It's more than a pivot. It's about fundamental economics and geology. It comes down to scarcity and stability.
I was looking at the data from Bencham. The numbers are almost funny. Lithium is what? 0.006% of the Earth's crust?
0.006%. It's exceptionally rare, and it's concentrated in very specific places. You have the lithium triangle in South America, some in Australia. It creates a choke point.
A geopolitical risk.
Exactly, and massive price volatility. We saw lithium carbonate prices jump from 50,000 yuan to 170,000 yuan in a really short time. You can't run a car company like that.
You can't plan. Your most expensive component triples in price overnight.
Yes.
So sodium is the hedge.
Sodium is the equalizer. Compare that 0.006% to sodium's 2.3%. It's the sixth most common element on the planet.
It's everywhere.
It is everywhere, in the ocean, in salt mines, and that abundance means cost stability. These sodium-ion packs are already coming in around $100 per kilowatt hour.
While lithium has been bouncing around $150.
Right, and $100 is just the starting point. The stability of that price is just as important as the price itself.
Okay, but this is my skeptical moment. If it's so cheap and abundant, why didn't we start with sodium? There has to be a catch.
There is a catch. Physics isn't a free lunch. The issue has always been energy density.
Okay.
If you look at the periodic table, sodium is right below lithium. It behaves similarly, but the ion itself is physically larger, heavier.
So it's the big-boned cousin of lithium.
In a way, yeah. It's harder to pack them into the cathode. Historically, that meant sodium batteries were just too heavy and didn't hold enough charge for a car.
The death knell.
Yeah.
You don't want a heavy battery that barely gets you to the grocery store.
Precisely. The consensus was it would be great for stationary storage, where weight doesn't matter. Generic sodium ion is around, say, 100 to 160 watt-hours per kilogram. High-end lithium pushes 270.
That's a huge gap. That sounds like a deal breaker.
It was a huge gap, but this is the breakthrough. CATL's Naxtra tech, they're hitting 175 watt-hours per kilogram.
175. Is that number? Is that enough?
It's the tipping point, and Samukai 5 puts it right on par with LFT batteries, lithium iron phosphate.
Which is what's in the standard range Teslas, the workhorse battery.
It's the workhorse of the modern EV. So sodium has effectively caught up to the standard tier of lithium. It's crossed the threshold from too heavy to viable for mass market cars.
That's the key, isn't it? We obsess over these huge range numbers, but most people are just driving to work.
And that brings us to the actual driving experience. The driver doesn't see the raw material costs. They care about what the car does.
Right. So the Nevo A06, it's got a 45 kilowatt-hour pack. They're quoting about 400 kilometers of range.
Roughly 250 miles, which is very solid for a daily driver. And they see that going up to 500 or 600 kilometers soon. But focusing on that top range number actually misses the real story here.
The superpower.
Yes, the superpower.
I love that we're calling it that. But it really seems to be the killer app for this chemistry.
It is.
Anyone who drives an EV in a cold climate knows the pain. You wake up, it's freezing, and your range is just evaporated.
It's the nature of lithium-ion. The reactions just slow way down. You can lose 30, even 40% of your range just because it's cold.
It's the #1 question I get. What about winter?
Sodium-ion basically solves this. The chemistry is just so much less sensitive to the cold. The data CATL released is incredible. At minus 20 degrees Celsius, that's minus 4 Fahrenheit, the Naxtra battery keeps over 90% of its discharge capacity.
90%. At minus 4, my phone shuts off if I leave it in the car at those temps.
It's unheard of for lithium. And it gets better. At minus 30 Celsius, the discharge power is nearly triple that of an LFP battery. They have it working down to minus 50 Celsius.
Minus 50. That's Antarctic Explorer territory.
It means for a driver in Minnesota or Norway, the winter penalty is just gone. The range you see is the range you get all year.
That alone seems like it could sell cars. That reliability is huge.
Reliability and safety. There's another layer here. The torture test.
Well, the sawing test. I saw that in the notes and thought it was a typo.
No typo. Sodium batteries are generally less prone to thermal runaway, but CATL wanted to prove it. They took a fully charged cell and crushed it, drilled it, and sawed it in half.
And with a lithium battery, that's a fire. A big one.
An immediate fire, yeah. With the sodium cell, no smoke, no fire, nothing. It just sat there.
Wow. Okay, that's reassuring. But there's a logistical benefit too, right? Something about shipping.
This is a bit of a deep cut, but it's huge. You can discharge a sodium-ion battery all the way to 0 volts.
Totally dead.
Completely inert. You can't do that with lithium. You'd ruin the battery. So lithium packs have to be shipped with a partial charge.
Which makes them hazardous goods.
Exactly. Live ordnance, basically. It drives up insurance and complicates logistics. Sodium batteries can be shipped as simple bricks of metal and then charged up at the factory.
That has to save a fortune.
It streamlines everything. It's one of those invisible things that makes the car at the end cheaper.
Okay, so let's zoom out. Cheaper, common materials, safer, and it dominates in winter. Is this the end of lithium? Is this a Betamax versus VHS moment?
Not quite. And CATL's own CTO, Qiyuan, was very careful with his words. He called this the start of a dual chemistry era.
Meaning they coexist.
They have to. Remember that energy density gap? Sodium has caught up to the low end of lithium. But if you want a luxury EV that does 0 to 60 in 2 seconds and goes 500 miles, you still need high-end lithium batteries.
So it's about segmentation.
Yeah.
Lithium is premium fuel, sodium is regular unleaded.
That's a great analogy. Lithium is for the Ferraris and the long-range cruisers. Sodium takes the Honda Civic market, the city cars, the delivery vans, and, crucially, the stationary storage market for the grid.
Right, where weight doesn't matter, but cost is everything.
Exactly. Sodium will likely dominate that sector, which frees up the lithium supply for the cars that actually need it.
So it's not a war, it's a partnership. Sodium relieves the pressure on the lithium supply chain.
It creates resilience, and CATL is betting on this whole ecosystem. They announced something called CHACO-Swap.
A battery swapping infrastructure.
A modular one, yes. And they plan to deploy 3,000 of these stations by 2026. But look at the strategy. 600 of them are targeted specifically for cold northern regions.
Connecting the dots.
Yeah.
They're putting the infrastructure right where the cold weather anxiety is highest.
It creates a complete solution. It really feels like the industry is growing up. We're moving beyond the one-size-fits-all EV.
We're seeing specialization. Different chemistries for different drivers, different climates, different budgets.
That's the sign of a mature technology. It's moving out of the early adopter phase into mass adoption.
And since CATL supplies almost everyone, Tesla, BMW, Ford, the tech, in this Chinese sedan today could be in a Ford Fiesta in Europe in just a couple of years.
I would say that's inevitable, especially for entry-level models. Everyone wants that $25,000 EV. The math is really hard with lithium. With sodium, it suddenly looks a lot friendlier.
It's exciting. I mean, we joked about driving on salt, but the implications are really serious.
It forces you to ask a bigger question. For the last century, mobility was tied to scarcity. Oil is scarce, lithium is scarce, but sodium?
Nobody goes to war over salt.
Not anymore. If the primary storage for our transportation becomes as common as dirt, what happens to the economics of just moving? It's not just about cheaper cars. It's about decoupling mobility from resource scarcity entirely.
That is a wild thought to end on. A world where mobility just floors out because the materials are everywhere.
It changes the entire map.
Well, before we wrap, I want to take a moment. We know we have a lot of diehard EV enthusiasts listening today. The people who know their NMC from their LFP.
The ones who have been patiently explaining to their neighbors why their car works in the winter.
Yes. We know you dive deep into the specs, so thank you for tuning in and geeking out with us on, sodium-ion lattice structures.
Yes, thank you. Your curiosity is what drives these deep dives.
And hopefully this gives you some new ammunition. The next time someone says EVs can't handle the cold, you can just look at them and say, have you heard of Naxtra?
And then hit them with a 90% retention rate at -20.
Exactly. Use the stats. That's what they're there for.
That's all for this deep dive.
We'll see you next time. Stay curious.